Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Rashidi bin Zainul Pajari. My meter number 01TPU21F1073. Today I will explain simple gas turbine power plant. A simple gas turbine power plant consists of several key components that work together to generate electric power. Here's a brief explanation of the main elements. Okay, for the first one, intake. The intake is the process begins with the intake of atmospheric air. For second, compressor. The air is then compressed to higher pressure in the compressor. This is typically achieved through the use of axial or centrifugal compressor. Third, combustion chamber. The compressor air is mixed with fuel, commonly natural gas or liquid fuels, and combustion occurs in the combustion chamber. This produces a high energy gas. 4. Turbine. The high energy gas expands through a turbine. The turbine is connected to the compressor through a shaft, and as the gas passes through the turbine blade, it causes the turbine to rotate. 5. Power generation. The rotating turbine is connected to a generator. As it turns, the generator produces electricity. 6. Exhaust. The high energy gas, now at a lower pressure, is expelled through the exhaust system into the atmosphere. The overall process is often referred to Brayton cycle. One of the key advantages of a gas turbine power plant is the high power to weight ratio, making them suitable for various applications, including aviation and power generation. They are known for their efficiency and ability to start quickly, making them valuable for meeting sudden increase in power demand. However, they may have lower efficiency compared to some other power generation technology, especially in application where constant high power output is required. Thank you for listening.
Good morning, ladies and gentlemen. Today, we dive into the intricate working of a gas turbine power plant, focusing specifically on the pivotal role played by the compressor in this remarkable system. The compressor, a fundamental component in the very core of this process by enhancing the incoming before it enters in especially system. Combustion chamber. Firstly, the system intakes ambient air which undergoes filtration to eliminate impurities on purified. The air enters the compressor section. The compressor composed of various stages with meticulously designed blade and stator perform a critical function. As a move through each stage, its pressure and density surge significantly. This compression raises the air temperature substantially, creating high pressure, high temperature air ready for the combustion chamber. Type of compressor. 1. Centrifugal compressor. Centrifugal compressor are used to power gas turbine engine used in energy production and other heavy industry applications. In a gas turbine, the centrifugal compressor transfers energy from impeller blades. The centrifugal compressor, which implies radial movement of air through a diffuser and impeller, increasing its pressure. Second, axial compressor. The axial flow compressor, known for its axial movement of air through multiple stages of rotating and stationary blades. Good for high compression ratio 21. It's also most commonly used. The function of combustion chamber. The combustion chamber serves as the heart of a gas turbine power plant where fuel and compressed air undergo controlled combustion to produce high temperature and high pressure gas. Its primary function is to facilitate the efficient and controlled burning of fuel within a high pressure environment. Compressed air previously prepared by the compressor enters the chamber and simultaneously precise amount of fuel are injected. The injected fuel atomized and mixed thoroughly with the compressed air, creating a homogeneous mixture suitable for combustion. Upon ignition, whether through a spark plug or due to existing high temperature and controlled combustion, reaction occurs releasing heat energy. This rapid energy release significantly elevates the temperature and pressure of the gas within the chamber. The resulting high temperature, high pressure gas then expand and flow through the turbine, driving its blades and generating mechanical energy. This mechanical energy in turn powers the generator producing electricity. The efficiency of the combustion chamber directly impacts the overall performance and energy output of the gas turbine power plant. Thank you.
Okay, how do turbine work? Wind turbine work on a simple principle. Instead of using electricity to make a wind like a fan, wind turbine use wind to make electricity. Wind turns the propeller like blades of a turbine around a rotor which spins a generator, which creates electricity. Okay, for the next is what is the function of a turbine? A turbine is a mechanical device that converts energy from a fluid or gas into mechanical energy. The most common type of turbine is a steam turbine, which converts the energy of steam into mechanical energy to drive a generator that produces electricity. Other type of turbine include gas turbines, which use combustion to drive a turbine, and wind turbines, which convert the energy of wind into mechanical energy. Okay, for the last is the process of turbines. Firstly, fluid intake. Turbine often work with fluid like steam, water, or gas. The process begins with the intake of a high pressure fluid. Secondly, nozzle expansion. The high pressure fluid is directed through nozzles, causing it to expand. This expansion result is high speed jet of fluid. Thirdly, blade rotation. The high speed fluid jet impact the turbine's blade. The blades are designed to capture the kinetic energy of the fluid, causing the turbine to rotate. Next is mechanical energy transfer. As the turbine's blades spin, they transfer mechanical energy to a shaft connected to a generator or other machinery. Next is energy conversion. The rotating shaft is used to generate electricity, propel an aircraft, or perform other types of mechanical work depending on the application. Last is exhaust. After passing through the turbines, the fluid exists at the lower pressure, having given up some of its energy to the turbines.
Hello, my name is Muhammad Azri Dazram bin Ruslan and my matrix number is 01DPU21F1042. So today I will present about advantage and disadvantage of gas turbine. The advantage of gas turbine is high power to weight ratio. Gas turbine offer a high power output relative to their weight, making them suitable for application with constraints like aircraft propulsion. Second is efficiency. Gas turbine can operate at high efficiency level, especially in continuous steady state condition, making them suitable for power generation. The third is quick start up. Gas turbine can start and reach full power rapidly compared to some other power generation technologies, allowing for responsiveness in meeting demand. The fourth is versatility. Gas turbine can use various fuels including natural gas, diesel, and aviation fuels, providing flexibility in different applications. The next is disadvantage of gas turbine. First is high initial cost. Gas turbines can be expensive to manufacture and install, which can be significant drawback in terms of initial investment. The second is maintenance cost. The maintenance of gas turbine can be costly, and regular inspection and repair are essential to ensure optimal performance and longevity. Third is emissions. Gas turbines may produce higher level of greenhouse gas emissions, such as carbon dioxide and nitrogen dioxide, compared to some alternative power generation methods. The fourth is efficiency at part load. Gas turbine may experience reduced efficiency at partial loads, which can be a drawback in application with variable power demand. It is essential to consider this factor based on the specific requirement and context of application when evaluating the use of gas turbine. That's all from me. Thank you.